Okay, so it takes the ball. Does it take? This is. Does it take the ball? Does it take longer for the ball to rise to its maximum height or to fall from its maximum height back to the height from which it was thrown? Justify your answer. Now, since air resistance, of course, normally you would say, oh, it's equal, but we have air resistance to consider. So the answer is longer to fall. Here's how I see it. This isn't the answer that the AP people gave, but this is how I look at it. Okay, so you throw it up in the air, right? And it's got, you saw your free body diagram, air resistance, acceleration due to air resistance and weight. They're kind of pulling it down. Okay, then on the way down, they are just opposite. But your air resistance builds until at some point before, presumably you hit the ground, you reach your terminal velocity where they're balanced. Now, at your terminal velocity, acceleration equals 0. So, basically, what's happening is that you're going to have a constant velocity at some point here. So if it's traveling at a constant velocity, it's not accelerating. So it's neither slowing down nor speeding up. So the way I would have written this is, since it reaches its terminal velocity on the way down, then velocity down will be less than, or actually I would put will, sorry, that was my alarm, will not reach velocity initial. Is that what they use for velocity initial? I'm going to say that's whatever they use for velocity initial. I'm doing this the next day. Okay, will not reach your initial velocity. Okay, and since the distance is the same, I don't know, trip down takes longer. The trip down takes longer. They did this with mechanical energy. I think this is fine. I don't see why you wouldn't get points for that. So I guess mechanical energy, what they're saying is it gains potential, or you go from kinetic to potential. Oh, it's kind of saying the same thing if you think about it. I'll let you figure out the mechanical energy one.